Hello, my name is Muhammad Ammar bin Alias. Today we will find out where the function goes up, increase, and goes down, decrease. First step, we need to find out the derivative function from the function. The s to find the slope of the graph. As you can see, we got cx squared minus 18s plus 12. For the next step, we need to find the critical point. To find critical point, we need to divide our function with c. And we got cx squared minus 3x plus 2. To find x, we need to find two numbers that multiply, we got 2. And if we plus it, we got negative 3. And the answer is negative 1 and negative 2. And the value of x is 1 and 2. For the next step, we need to do a test to find out the sign of x is positive or negative. If the sign of x is positive, it means it's increasing, and if it negative, it means it's decreasing. So as you can see, the test point 0 and p is increasing, and the test point of 1.5 is decreasing. So the function is increasing before 1 and decreasing between 1 and 2 and decreasing again after 2. So in conclusion, f function is increasing on interval negative infinity 1 and 2 infinity and decreasing on interval 1 and 2. For the next question, I will show you how to derive the total revenue function at Q for demand function. It is given that PQ equal to 100 minus 4Q. The total revenue is simply a price multiplied by quantity. So we need to multiply the function with Q. So we got at Q equal to 100Q minus 4Q squared.
Good evening, doctor. My name is Li Wei Hang, and now I'm going to proceed with the first question, 1b Roman 2, which is determine the concavity of the revenue function. So based on the first derivative function from B1, we can find that the R prime function is equal to 100 minus 8Q. So to find the concavity of the revenue function, we need to apply the second order condition, or known as second derivative for the function. So after applying that second order condition to the first derivative function, we can conclude the answer is R double prime equal to negative 8 less than 0. Since negative 8 is less than 0, so we can conclude that the revenue function is concave downward. Now I'm going to proceed with question 1 Roman 3. Find the output level at which total revenue is maximized and interpret the result economically. So first of all, we have the R prime function is equal to 100 minus 8Q. Let the R prime equal to 0, and we will get 100 minus 8Q equal to 0. And then moving the negative 8Q from left hand side to right hand side, the negative sign will be diminished, and we will get 100 equal to 8Q. And then moving the 8 from right hand side to the left hand side, from multiply to divide, we will get Q equal to 100 divided by 8. Then solving the 100 divided by 8, we will get 12.5 units. And lastly, we will round off the quantity. We will get the output level at which total revenue is maximized is equal to 13 units.
Hello everyone, my name is Kim Yan-Ping. My matrix number is 311891. Today I want to explain the question number 2a. The total cost TC of a company is given by the question. TC equal to 100 plus 2Q plus 0.1 Q squared, where Q is the quantity of unit produced. Question number 1 is calculate the marginal cost MC for the company. So now we differentiate term by term. For the first term is 100. This is a constant, so the derivative is 0. For the second term is 2Q. When we differentiate 2Q, we can get 2. So the third term is 0.1 Q squared. When we differentiate Q squared, it becomes 2Q. So 0.1 times 2Q give 0.2Q. So the MC is 2 plus 0.2Q. Next is question number 2. Determine if the marginal cost is increased or decreased as production increase. We look at the MC equal to 2 plus 0.2Q. This is a linear equation in Q with a positive effect on Q. The slope is 0.2 is positive. That means when Q increase, 0.2 also increase. So the whole marginal cost becomes large and large. Therefore, marginal cost is increased as production increase.
Now I'm going to proceed with question 2b. The price function for a product is given by P equal 100E exponent negative 0.05Q, where P is the price per unit and Q is the quantity of output. So the first question is find the quantity that maximizes revenue. And the second question is determine the intervals where total revenue is increasing and decreasing. So now we are going to find the quantity that maximizes revenue. So first step is we need to find the total revenue function, which is TR. So total revenue equal to profit multiplied with quantity. Profit has been given by the question, which is 100E exponent negative 0.05Q multiplied with Q, which is quantity. And then we will get the total revenue function, which is 100QE exponent negative 0.05Q. The second step is we need to find the first derivative of total revenue function. So we will apply the product rule on the total revenue function and let the S become 100Q and let the Y become E exponent negative 0.05Q. After derive the derivative, the S and Y value, we will get S prime equal to 100 and Y prime equal to negative 0.05 E exponent negative 0.05Q. And then we will substitute the value into the product rule formula, and we will get 100 bracket E negative 0.05Q plus with 100Q multiplied with bracket negative 0.05 E exponent negative 0.05Q. And then, so by solving the numbers, we will get TR prime equal to 100E exponent negative 0.05Q minus with 5QE exponent negative 0.05Q. Since the factor is the same, so we factor out 5E exponent negative 0.05Q bracket 20 minus Q. So let's proceed with the step 3 to find the maximized quantity. So we take the total revenue function that has been derivative in the step 2, which is 5E exponent negative 0.05Q bracket 20 minus Q equal to 0. And then we take out the value in the bracket, which is 20 minus Q equal to 0, and solve the equation, which we will get Q maximized quantity is equal to 20 units. And the second question is to determine the intervals whether it is increasing or decreasing. So the first step, we need to draw a S-axis to determine the two intervals. So we will get the first interval is 0 and 0, 20 and also 20, infinity. So for the first interval 0, 20, we need to pick a test number. From 0 to 20, I pick 10 as my test number. After selecting the test number I want, and then we need to substitute the number into the total revenue prime function that we have been derivative in step 2. And then we will get a value which is 30.33. Since there is no negative sign on the answer, so we can write the sign off which is positive. And then if the sign off is positive, means that the slope is increasing. And for interval 20, infinity, the test number I pick is 30. And after substituting the value, I will get negative 11.16. It's negative 11.16. So since there is negative sign, so the sign off is negative. And then if the sign off is negative, so the slope is decreasing. So if the slope from positive to negative means that 20, the maximized quantity 20 units is the maximum point of the total revenue function. That's all from me. Thank you.
Good afternoon, Doctor. My name is Sun Ching. Today I will introduce about question 3. A local manufacturing company demand function Q minus 90 plus 2P equal to 0 while aim to maximize its profits. The company is AC equal to Q square minus 8Q plus 57 plus 2 divided by Q. Firstly, find the value of Q for which the profit is maximized. Second, using the second order condition, prove that the quantity in one result in a maximum profit. First question, find the value of Q for which the profit is maximized. Express price in terms of Q. So that we need to use the equation Q minus 90 plus 2P equal to 0 become P equal to 55 minus 0.5Q. Secondly, we find the total revenue TR. TR equal to P times with Q. So that we need to use the equation of P times with Q again. So that we can get the TR equation become 45Q minus 0.5Q squared. Total cost DC. DC is equal to AC times with Q. So that we need to use the equation Q squared minus 8Q plus 57 plus 2 divided by Q times with Q again. So that we can get the equation Q cubed minus 8Q squared plus 57Q plus 2. We need to find the profit function with TR minus TC so that we can get the profit function with equation negative Q cubed plus 15 divide 2Q squared minus 12Q minus 2. So that we need to use the FOC differentiate profit with respect to Q so that we can get the equation Q squared minus 5Q plus 4 equal to 0. So that we can get the factor of this equation is Q equal to 4 or Q equal to 1. Using the second order condition, prove that the quantity in one result in the maximum profit. So that we need to differentiate this equation become Negative 6q plus 15. Using the second order condition proves that the quantity in 1 result in a maximum profit. While q equal to 1, we sub into the equation can get positive 9. Positive 9 is greater than 0, hence q equal to 1 is a minimum point. While q equal to 4, we sub into the equation can get a negative 9. Negative 9 is not greater than 0, hence q equal to 4 is a maximum point. Since the second derivative is negative, the profit function is concave downward at q equal to 4. Q equal to 4 give a maximum profit.